Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning, and you're all very welcome to another Signpost Series webinar. I hope you're all keeping well this Friday morning. Today, we're going to be discussing spring nutrient use, reduce losses, and improve returns. So, with ever-increasing pressure to reduce the impact of agriculture on waters and environment, now more than ever before, farmers are looking for ways to better utilise nutrients. And we're delighted to be joined today by Fiona Doolan, Teagasc ASSAP Advisor. Good morning, Fiona. How are you keeping?
Good morning, Cathal. How are you?
Good, you're very welcome to the show. We're also joined by Eoghan O'Brien, who's a Teagasc ASSAP Advisor in Carlow and Wicklow, who's going to assist us with questions later on. Fiona, just before we get into your presentation, maybe you'll tell the viewers where you're based and maybe a little bit about what the role of an ASSAP Advisor is.
Sure, Cathal. Yeah, I'm based in counties Kildare and Laois. I've been an ASSAP Advisor here since 2018. And I suppose really the job is all about helping and supporting farmers to address any potential issues they have on their farm and to try and give them practical solutions, really, that they can put in place on their farm to ensure that there's minimising any risk of any loss from that farm, because ultimately they, no different to us and the industry, all want to see water quality improve. And there's a great pride in our countryside, our farms, our natural resources. So it's about helping individual farmers for their individual farms to achieve that, really.
It's probably one of the first times, Fiona, that you have an advisory service that just goes out for a walk with the farmer one-on-one, and it's looking at stuff not just in the yard, but beyond the yard, I suppose, where people will be more used to thinking about water quality.
Yeah, you're absolutely right, Cathal. I mean, we look at all the different aspects that are there in financial performance, physical performance on farms, regardless of enterprise. But this is the time of really specifically looking at the environmental side of the house, looking at water quality and seeing the interactions there, where improvements can be made, where tweaks can be made, adjustments made, that you're not impacting on the financial viability of the farm. In fact, probably securing that in the long run by ensuring that it's also married in well with, with water quality and reducing impact there as well,
So Fiona, if you're ready to roll, we'll let you go.
Thanks, Cathal. So yeah, just, the topic today, spring nutrient use, how to improve returns from those nutrients, but crucially, how to reduce losses. So hope to hit on some of the kind of the tried and tested practices that we know will make a difference, but also maybe to give a nod to some of the newer technologies that are there and tools that can help us do that. I suppose in terms of what I want to cover today, I think it's a good time to go back and look at the composition of the organic manures that we have available to us and up-to-date values on those to kind of set the scene, but also then how to get optimal use out of those. So I suppose really what I'm talking about here is where to spread, when to spread, how much to spread, the practical issues like that. But also keeping in mind, how do we make sure in doing that we're reducing losses to the environment and specifically to our water courses. I think it'd be nice to throw in a case study into this too, to see how that might look in practice on a farm, and to draw some conclusions out of that. I suppose I'm always minded that, we hear this phrase, the right time, the right place, the right rate, but, put some meat on that. What does that actually look like in practice? And I suppose, it's also, when we talk about reducing, reusing, recycling in society today, I'm always thinking that, the farmer is really the original of the species when it comes to recycling. We're taking, a byproduct of our industries, applying it out onto our land, our grass-based system then producing really high quality milk and meat from that, and from our cereal lands as well, producing really top quality crops. And then the cycle begins again, because as those crops or grass or cereals are fed to our livestock and to our pig and poultry industry, we've more byproduct again to go back out and recycle. So it's this sustainable kind of a cycle that's there. And that's what will add to, to our long-term viability. But there's a crucial point in those three photographs. It's to ensure that in all of that system, we're not looking at losses that will impact on our environment and particularly water quality. So really what I'm talking about here is the nitrogen and the phosphorus that we have available to us, that we use it efficiently, we use it effectively, we get maximum return off of it, but that we ensure in doing that, that we're not losing those nutrients to our water courses. Because of course, water quality is on the tip of everybody's tongue, whether you're a farmer, whether you're involved in the wider industry or the agri-food industry, water quality is crucial. We have our binding targets that we must meet under the Water Framework Directive. So we have to be always cognizant that in all this recycling and using and efficiency and production, that we're not losing that and creating another problem somewhere else. And I suppose to that mind, last year, the Better Farming for Water campaign was launched. And Teagasc was last to lead out on a whole of industry campaign to address water quality issues. And in that, there are 8 actions for change, or 8 specific asks of farmers as they go about their farming activity. And today, really, there's 3 of those actions that I want to hit on. The first 3 actions out of those 8 refer to nutrient management. So if we look at them, and our first action is about reducing purchased nitrogen and phosphorus surpluses on farms. And that really, in simple terms, is about getting the maximum out of our organic manures that we do have available so that we've less reliance and less surplus on our chemical side of the house. So that's really about the plan and the things I'm going to hit on today to make maximum efficiency out of those organic manures. If we do that, we will reduce our reliance on the chemical. It's there as a top up, as a safeguard, but that we're really cognizant then of reducing balances there. And the second action out of that there is, if we look at it, is soil fertility, is ensuring that we have optimum soil fertility where it's needed. And I will touch on that later on. And again, that's all about targeting and effectively targeting those organic manures to where they're needed and where they'll give return. That will really feed in then to improving our nitrogen use efficiency in particular, and reducing the risk of nitrate leaching. We hear about nitrate levels in our water bodies and our estuaries, but by really targeting actions 1 and 2, what we're trying to do is reduce the levels of those nitrogen that we are seeing leached from our lands. I suppose the third part then is we're going to use organic manures in particular to address 1 and 2. Well, then we have to make sure that when we are spreading these fertilizers, they're going at the appropriate times and the appropriate conditions to minimize any loss off of those. So I suppose, look, really, those 3 actions are key. And that's what I'm going to focus on today, because that's really at the start of the year now is kind of the time when we can really be fresh in our minds, put a plan in place, really get the most out of it, but also knowing that we're holding on to what we need to, and there's less loss there that can have a negative impact on our water quality. So I suppose, look, to go from there, I said the first thing I just wanted to look at was to refresh in our minds organic manures that we have available to us, what they can potentially provide in terms of nutrients and their values. So really just looking at up-to-date values, February 2025, of the organic manures we have. If we take, a typical cattle slurry, a 6% dry matter cattle slurry, the nutrient composition of that is equivalent to a compound 9,532. So we've, a lot of nutrient already there in this slurry, spread across that nitrogen, phosphorus, and potassium. And at current fertilizer values at the minute, 1,000 gallons of that typical cattle slurry is worth in around €28 per 1,000 gallons. So it's a very valuable resource on the farm. If you compare that to, say, someone who has pig slurry available to them, a slightly different nutrient composition, probably closer to 19,720, and subsequently then a higher value in the region of €33 per 1,000 gallons. So these are valuable organic manures that we have to hand. And I suppose the only caveat with that is that, should chemical fertilizer prices rise or fall, that impacts on the value of those. So if we do see a rise in chemical fertilizer prices, the value of organic manures will also rise. I suppose just a nod while we are on that table, because it is up to date, is to look at some of the other type manures that may be available. So more solid type manures, think about farmyard manures, particularly poultry manures, broiler litter, the like of that. We're looking at a completely different nutrient content in those, typically very much higher on the nitrogen side of the house. And, subsequently, we could be looking at manures that are values up to 20, 30, 50 euros per tonne. But there is also a risk involved in those, because a lot of that value is tied to that really high nitrogen content. We have to be extra cautious about where they go out, the rates they go out at, and time them critically to a growing crop to maximize the uptake. Because from a water quality point of view, if they go out at the wrong time, where there is no or little demand, then there's much greater risk of that nitrogen ending up where it shouldn't go. I will mention that later on, but it's just to be cautious that, high nutrient content manures also carry a risk with them as well, and we need to be conscious of that. I suppose as advisors, we're often asked about, the variability in the nutrient content of slurries, and the impact that maybe the diet of the animal might have on it, the level of concentrate feeding, the type of concentrate feeding, and so on and so forth. But I suppose really and truly, the biggest impact on the nutrient content of those organic manures is related back to the dry matter. So how much water are we talking about in these? And just the table I'm flashing up there in front of you will show the nutrient content of a typical cattle slurry going from 2% dry matter right up to 7%. And if you look at the levels of, say, potassium that's contained in those slurries, it triples as we go from a 2 to a 7% dry matter. Similarly with your phosphorus levels, it triples as you go from a 2 to a 7% dry matter. So I suppose the point I'm just trying to make here is that all slurries are not equal. When is 1,000 gallons of slurry not 1,000 gallons of slurry? Well, it might be 1,000 gallons in volume, but the nutrient there could be very, very different. And, when it comes back to those actions we talked about optimizing fertility on soils, about, reducing our chemical nitrogen surplus, knowing what's in the organic manures you're spreading is crucial if you're going to match those, improve our nutrient use efficiency, and reduce the risk of surplus nitrogen, for example, being in the system. And that's why I've shoved in, the little photograph down the bottom of the slurry hydrometer. It's very simple to carry out that on your own farm at home, on the agitated tank of slurry, get a dry matter, and we know there's a really, really good correlation between it, and you'll get a very good idea of what you have in hand. And the other thing is, look, the number of you have, different tanks in the yard, and there might be various different, it could be open tanks taking rainfall, roof tanks with very high dry matter slurry. There might be a variation even there within your own yard. It's to be cognizant of that and to target it to the right places so that we can, make better use and improve our nitrogen use efficiency. And I suppose, when you do look at trying to target those to where they should go, which of those slurries would you rather be going out onto a field that's an index 1 for P and K? It certainly wouldn't be the likes of the soiled water or the low dry matter slurries. You'd be trying to get out that higher dry matter where there's a bigger concentration of nutrient. It's expensive to spread slurry. It's expensive to keep tractors and tankers on the road and burn diesel. Make that 1,000 gallons make a difference once it's targeted where it's going, and you'll only know that by knowing, I suppose, what's there in it. So I think that's something timely that we could all really explore at this stage of the year before big volumes are spread. And I suppose just then to move on to the whole nub of the thing, the right place, the right time, the right rate, to get into that kind of questions. I suppose, look, in 2024, something over 60,000 soil samples were analysed through the Teagasc soil sample system. And to give you an idea of what those soil samples shown, I've just thrown up a table there that covers both the phosphorus and the potassium indices of those soil samples analysed last year. The darker green colour are the phosphorus indexes for those samples. The lighter green colour are the potassium indices. If you just take a look at the phosphorus for a minute, you'll see that really there's almost an equilibrium there between the four classes. Index 2, 3, and 4, all at 26% of the soil sampled in each of those classes, slightly less than Index 1. So there is a spread in all the samples we've seen analysed last year, and there is a variation from 1 right up to 4. Variation is different, is higher actually on the potassium. We've a lower level at Index 1 and a higher level at Index 2. But I suppose the point I'm trying to make here is that finding the right place on your farm is about looking at how we can address that. Last year on those samples, about 17% of the total samples that went in were at optimum levels of PK and lime. So it's not that every acre on the farm needs to be there, but those areas that you're really dependent on, say your silage ground, where you're really dependent on taking a large portion of your annual forage budget off from, really needs to be the ones that are optimum. So we've seen a bit of a rise there. We're up to 17%. That's good, but there's quite a range within the enterprises. In terms of the P and K indexes, we've seen a slight drop in the number of samples that are Index 1 and 2. Not huge drop, but a slight drop there. But what we're still looking at is, look, we have a large portion of the samples that are going through are still at Index 4. And there's surplus P and K in the soil compared to what the crop is demanding. Yet we also have quite a portion of our soils that are still at Index 1. So the right place on your farm is really about trying to rebalance that distribution to get some of the nutrient that has been going out on those Index 4 soils and redistribute it back to our 1s and 2s to try and build up the baseline fertility there. If we can do that, then we will see an improvement in our nitrogen use efficiency in particular, and we will be able to address that nitrogen balance on farm and reduce the balance. If we can reduce the balance, we will reduce the risk of nitrate being lost into those estuaries. So really that's something that I think we can have a good think about at the start of the year and really put a plan in place to address that as we go. But in terms of how we address that, what are the steps involved in doing that on your own farm? I suppose the first step is always, as you said, is taking those soil samples and taking them correctly and accurately. And the second point is probably to go first and foremost to the lime requirement. We know there's long-term benefits there that will be seen over multiple years, not just the year that it's applied in. And only when that pH is addressed to then look at, the indexes, the baseline fertility that's there on the farm. And there's a real conversation that needs to be had there between the farmer and the advisor in order to get those 3 steps in place first. And then it's really about acting on it, about actions to address those. So when you get on to the next step, it's about first and foremost, making use of the organic manures that are to hand, targeting them right as per your previous conversation with your advisor. And it's only when those organic manures have been used and targeted correctly that we then look to chemical fertilizer. So chemical fertilizer shouldn't be the first port of call. It should really come in second to organic manures and act as a top up then to address any remaining deficits. And that conversation should really be held, there should be a really good line of communication between the farmer and contractor, if it is a contractor being used, or between the farmer and whoever it is that's on the farm that's spreading slurry. So it's clear, it's understood, what's going where it should go and the rate it should go at. And they are basic steps, but they're terribly important if we do want to really start, actioning that second piece there about optimum farm fertility and reducing the nitrogen balance on farms. I suppose then, just to talk about the right place, and where is the right place on farms for using particularly organic manures. And as I said earlier, if you looked at your typical cattle slurry composition 9-5-32, well, if we look at your 1,000 gallons of slurry or your tanker full of slurry going out the gateway, if we look at the composition there, almost 70% of that slurry is made up of potassium in terms of the nutrients N, P and K. 11% of it is phosphorus. So when you add the two of those together, 80% of the nutrient content of that slurry is P and K. The smaller portion, the 20%, is then nitrogen. So if we want to realise that 28 euros per 1,000 gallons, that slurry really has to be going to where that P and K is needed. And that's just the reality of it, that's the target. And if it's applied where it's required, where the crop needs it, and in good conditions, then we will realise that 28 euros per 1,000 gallons. But there's a caveat there, that if that slurry is going out to a field that's handy, close to the yard, that doesn't need it, that's index 4, it's just going there because it's the easiest place for it to go, then we're not, that crop doesn't need that P and K. It's not going to benefit from it. There was enough in the system already. And really, are we probably looking at closer, to the nitrogen portion of that slurry being realised? So your 28 euros now massively decreases down because the crop doesn't need what you're giving it. It's like going out for your dinner and saying, I'll have, meat, veg and potatoes, but actually I only want the meat. Well, what happens the other two portions? You don't need it. It's not there. It's a loss to the system. And there's probably somewhere else on the farm that actually needs it more. I suppose, the last point, and that is if you're going out onto index 4 soils where the crops don't need the P and K, and if you're going out in unsuitable weather conditions, so saturated soils or very poor or no growth rates, there's a question mark even over the amount of nitrogen that will be recovered out of that. So the right place to me is the place that needs it, the place that the crop needs it and will respond to it, and the place that you can therefore adjust down the input of your other chemical fertilizers to make best use of it. And I suppose, just following on from that then, the right timing and the right rate then, how do we decipher what that is? On your screens on the left-hand side, you'll see the grass growth curve, and I'm sure you're well used to looking at it, but it's worthwhile reminding that, our grass growth is on the floor when it comes to January. It's just basically ticking over. And it's really only when we get into, middle to the end of February that we really see an increase in growth rates. And then once we're into March, it really takes off, and uptake takes off as well. But if we break that down a little bit more and look at, I suppose, the demand, look at the grass growth per week, and look at what it demands in terms of nitrogen to support that growth. You'll see that the demand in the month of January is very, very small. And it's really when we get to the likes of February, and we get into February, you'll see the demand coming up. Our total demand there in the full month of February over the 4 weeks is probably something close to 11 kilos of nitrogen to support that growth. You can see how that increases then when we get to March, and as we get closer to St. Patrick's Day, it lifts, it takes off. We go up to probably closer to 16 kilos of nitrogen demand, and so on and so forth. But if we look at what slurry can provide in that scenario, if you look at, say, that month of March there, with that demand is growing, you're looking at probably 15, 16 kilos of nitrogen. Look at what can be provided with cattle slurry to meet that. If you're looking at something like 2,500 gallons of cattle slurry, will provide something like 28 kilos of nitrogen, which is in excess of what the crop will actually take up. So this is where the rate comes into it. I appreciate slurry has to be spread, tanks are full, but the rate is really important. Providing more that the crop will take up is not a good place to be. Adjust down the rates to match what the demand is, and leave that slurry there, that when growth really takes off, now we still have it there. It's like money in the bank, that you still have it there then to match when the demand really is there. And that's the piece about rate. It's been really, really conscious of matching, the demand to what's there, as opposed to just getting it out of a tank. I suppose you're coming back to the water quality element. If we are overdoing it on the rates, when the demand isn't there, there's surplus nitrogen in the system. And if there's poor crop demand and a free draining soil, we're now really into this whole area of nitrate leaching, losing nitrate down into groundwater, which cannot be taken back. And then you're into the subsequent issues with nitrate in our estuaries, and so on and so forth. I suppose, look, the last bit I just wanted to refer to, the right rate. Most farmers at this stage have a nutrient management plan. trust those. Look at your soil fertility maps. Put that nutrient management plan into place. Do you trust your soil samples? Well, if you do, that will direct you where to go with the likes of your rates and have the plan there, as opposed to just going out with X amount on X field. So it's use what we do have there. Soil samples are expensive. They're really good value if they're put into place, but if they're not used, then it's like the slurry. The value is reduced off them. I suppose, just one nod to the whole, to the cereal side of the house, and the option of using organic manures on tillage crops. Organic manures, where they're targeted to low P and K index soils, you really have potential there to build up that fertility status. There are options around spring application of organic manures to either, growing crops to the standing crop, or to be incorporated, maybe if it's a more solid type manure, prior to sowing in the spring. The key thing here is reducing the chemical fertilizer accordingly. So it's not just throwing out organic manure and continuing on with the same chemical fertilizer regime. That will not improve our nitrogen use efficiency. That will not do anything to reduce nitrate leaching. And that will not, in a sense, it's going to cost money that you're not going to recover back. So I think, reducing chemical fertilizer, but crucially, and I did refer to this at the start about those high nitrogen organic manures, the likes of those poultry manures, for example, avoiding high nitrogen manure application in the autumn. Because if you think about the autumn, if a winter crop has just been sown, the demand is very low, the crop is just establishing, to lob out 20 or 30 kilos of available nitrogen at that time of the year when there's no demand is a recipe for nitrate leaching. So avoiding at all cost high nitrogen manures late in the autumn time. And I just would refer to the fact that there's a really good simple video on the Teagasc YouTube, 7 actions for spring application of slurry to winter cereals, done by our colleagues Shay Phelan, crop specialist, and John Mann, Signpost Advisor. For anyone who is involved in tillage, has availability of organic manures like slurries, to see how that can be incorporated into the growing crop, and is worth looking at. So I suppose, look, the other side of it is, when we are using these organic manures, is to be conscious all the time about buffer zones. It's like putting on the safety belt when you get into the car. You don't want to have an accident, but if you do, you know that wearing your belt is going to provide you with some bit of protection. And those buffer zones are going to do the very same thing. The 5 metre buffer margin when spreading organic manures is there, whether it's grassland or tillage. It applies to both surface water drains and streams, because the surface water drains are as connected to our big water bodies as our small little tributaries. I suppose just a reminder that for those who are just coming out into the open season, that the 5 metres is 10 metres for very good reasons. But it's abide by those buffer margins. That's critical to ensure that there's no loss of phosphorus into those drains by surface runoff. And I suppose the other thing is, when we're in the open season, it doesn't mean that we won't get heavy rainfall, excuse me, and that that heavy rainfall creates another risk of runoff. So it's just been very, very conscious that open season does not mean it's free to go and put out at any time without having risk. There is real risk there, as was shown last year in the Agri Catchments programme with Eddie Burgess, where they showed us that really heavy cloudburst type events can deliver huge levels of phosphorus to our streams and watercourses. So be very conscious about the weather forecast and rainfall warnings. And I suppose, just to move on to the last piece of the presentation, to look at a case study to try and put some meat on the bones of what that might look like on a farm situation. My case study here is about where to focus organic manures to get the maximum return with minimum losses. This farm is based in the Barrow catchment. Water quality is already moderate in the area, and the local monitoring point is showing up high phosphorus. So what do we need to look at here? This is a typical dry stock farm. We're talking about 27 hectares of grassland carrying 40 suckler cows, a stocking rate of 150 kilos of nitrogen per hectare. Pretty typical. I suppose the question is, first and foremost, what's been produced on farm that's there at first hand to be used? How much slurry is actually produced? This farm is in a 16-week closed period. So over a 16-week winter, we're looking at the bones of 70,000 gallons of cattle slurry been produced on this farm in that 16-week period. That's there first hand to play with. I suppose in reality, I would say, in this farm, there's probably closer to 20 weeks slurry actually being produced. If you leave the closed season aside, the wintering period is going to be longer than that. And we're looking at probably closer to 20 weeks, which would be 87,000 gallons of slurry. What does that really mean or provide to the farmer? At the 16 weeks winter, there's probably at current prices, little bit less than 2,000 euros worth of nutrient there in the tanks after that period. That's quite a considerable amount of money for you to go out and have to spend it buying fertilizer. In reality, I'd say there's more, as I said, more slurry being produced than just over the 16 weeks. And at the 87,000 gallons, there's probably closer to 2,800 euros worth of fertilizer in those tanks. Or to put it back to our compound that we spoke of earlier, 9532, the equivalent of about 4.5 tons of fertilizer there in the yard. And I think we'd all agree we're much more conscious when you look out and you see the pallets in the yard and you see the fertilizer there, that its value, its cost, because we paid for it. Are we as conscious of the value that's there in the tanks? Maybe not. But the next key in this is, well, getting the most out of that then, getting that to where we're going to get the return without losing any nutrient to water courses. In my case study farm here, we have a home farm that's built around the farmyard and is pretty typical, I would say, of a lot of Irish farms, a fragmented farm. So we have an out farm 10 kilometres away. I think that's something we're all familiar with, and it's how do we manage both. I suppose the point I'm putting up here, as I'm going to talk you through, is that not every acre of land in this farm is the same, has the same requirements, or has the same risk either. And if we start to tease down through it, land around farmyards, I find typically is used for grazing and won't have the same requirement or the same demand as, say, land that's been taken for two-cut silage every year. So, while it's close by and it's at hand, and typically I would say has a higher P&K index than the further away land, arguably is the place that leads the slurry least of all. On this farm too, as with many other farms, there's a portion of leased land or con-acre land. And, how do we address that? That's expensive. It's expensive in the system, but sometimes we look at it and say, look, I don't own it, so I'm not going to lime it, or is it worth my while liming it or putting P&K on it? And maybe that's a bit of a conundrum, because it's expensive in the first case to lease. So, if it's poor fertility and it's been ran down over a number of years, that cost is probably increasing if we look at what it's producing. In this farm, as with a lot of farms in Ireland, a farm called the Bog, peat soils. Again, an area that we need to be very conscious of for losses, particularly of phosphorus. Peat soils, as we know, cannot build up phosphorus in the soil. It has no ability to build up. So really applying here maintenance just as we're going along. Is it high priority for slurry? I would say no either. It's probably an area that's there's somewhere else in the farm we're going to get better return off of, and that really peat soils need to be managed very, very differently. And as I said earlier, not every acre on the farm needs to be at optimum levels for P&K and lime. Typically we all have areas that are lower productive areas, low input pastures, extensive graze, and biodiverse swards. And really, that's probably not a place that will value additional nutrients, but also potentially could do harm to that, to those kind of more natural swards and the biodiversity that exists within them. So again, I'd be saying that's not a priority area for using your valuable 4.5 tons of compound that's in the yard. So, not every acre is the same and shouldn't be, and we need to, one size won't fit all here. So we need to be flexible and adjust. The other thing we do tend to see, though, is that there's grazing land on a farm that will accidentally or incidentally end up in a silage cut, and it was never fertilized for that. And fair enough if that only happens once in a blue moon, but if that's continually happening, then you really need to kind of think, well, am I robbing Peter to pay Paul here? Am I eventually going to run into a fertility problem there? Maybe I'd be better off having a better, more in-depth look at where I am planning for silage, fertilizing for it, and let my grazing be grazing. And I suppose the last piece of the puzzle then is we really have to address this issue of out farms and land that's away from the yard. It is more difficult, more awkward, more time consuming to transport nutrients to there. There is a cost involved, there's time involved, but ultimately this farm where the vast portion of silage for the winter is coming from a 2-cut system on it, it really has to be addressed, because that's where we need to ensure that we do have our optimum soil fertility, if that's going to provide 30 or 35 or 40% of our annual forage. And ultimately, the stocking rate I showed you at the start for this farm is based on the whole farm. If we have out fragments that are out farms that are a distance away, that are not getting slurries and are not being grazed, then that stocking rate is essentially being carried on the home farm, which really kind of puts a different spin on, the nitrogen input and the whole farm. When you look at organic plus chemical, we need to look at addressing and spreading that out respectively over the whole farm to balance that stocking rate. In terms of what do the PIP maps say about this land or this farm? Because, these are really, really useful tools that are available to us that can help us target where to be really conscious of, where the extra risk is, and how we need to address that to make sure that we're not losing that nitrogen and phosphorus to our water courses. In terms of our nitrogen risk maps, or nitrogen PIP maps, if we look at the home farm and we look at our legend at the bottom, we'll see there really is no risk, or we're the very, very low categories of PIP risk for nitrogen loss in the home farm. But if we look to the out farm that I mentioned before, and now you see the colour, the darker pink colour, we really see that, okay, there's risk attached here. This is likely to be very dry, free draining ground, land that can be got out on very early, it's trafficable. But that freer draining soil, as I said earlier, where the nitrate is present and crop isn't growing, poses a risk to our leaching. And this is where our nitrogen leaching is most likely to happen. The message here with this is that slurry going to that out farm needs to go when there is a demand, when that growth is there to take it up. And going back to our Action 2 and the Farming for Water campaign, this is really where we need to have our optimum fertility, so that the nitrogen use efficiency figure will be good here. We'll get bang for buck, in other words. So that's what the PIP maps are telling us for nitrate. Our risky area is the out farm. Optimum fertility needed there, and timing of that nitrogen to match crop growth rate. If we look at our risk maps for phosphorus, or our PIP maps for P, what's that telling us about the farm? And here we see the colour coming in. The darker colour, the darker blues, are the higher risk for phosphorus loss. So that's telling us that the home farm here, or the portion around the farmyard, is very high risk for losing phosphorus. So we're likely looking at a heavier soil, more difficult soil that isn't as free draining. So we're likely to get more surface water runoff. And if organic manures are present, when those soils are not at optimum ground conditions, and when we get heavy rainfall, we're likely to get runoff into drains and take that phosphorus with us. I suppose if we look at the out farm, it's the flip side of it, and we tend to see that if a field is high risk for nitrate loss, it's probably very low risk for phosphorus loss. So we've started a picture here now where our home farm is the area we really need to watch in poorer, wetter conditions, when soils are saturated and in heavy rainfall. And we add in the last layer of the puzzle, if we like, the flow path. So if we get heavy rainfall on this land around the yard, where is that rainfall likely to go? The flow path. What's the path of that surplus water over the ground to make it into the drainage network? And you'll see very clearly there are paths that are very high risk on this farm. When you add in where the surface water drain network is around it, we see there are a portion of land here that I would deem to be very high risk, outlined in the yellow in front of you. So when we are talking about spring nutrient use, that area within there is really where the highest risk is of loss to that network. So, this isn't intentional loss, it's incidental or it's accidental, but of all that farm that we're shown there in front of you, that's the one area where you need to be really critical about buffer margins, about timing, about rainfall, about saturated soils, about growing conditions to take up that nutrient, because if there is runoff into surface water drains, that's the highest risk area of it. And conversely, when you look at the out farm, we have no flow paths. That's to be expected. Free drain and soil, and that's where we really, where we don't have the risk of runoff, but we have more of an issue with timing and nitrate. So when you add all those two things together, there's a picture emerges of where the risk areas on the farm are, where they're not, and what you need to be conscious of with timing when it is going out. I suppose, oftentimes then when you look back to the nutrient management plan for a farm like this, you will see where where that nutrient has gone over time, and where the imbalance is seen. So for example, the out farm, that the distance, the issues with travelling is the place that sometimes it's a struggle to get slurry to those, and consequently we see low indexes of P and K on those. That needs to be addressed. And the wetter portions of the farm that are cut for silage, again, lower P and K, whereas when you look around the farmyard, you have this lovely index 4, but it's grazing ground that really the crop has sufficient amount of nutrient there anyway for. So it's redressing the balance in order ultimately to get a higher nutrient use efficiency, to capture more of the nitrogen in the system and reduce the chances of leaching, but also to capture the phosphorus that we're putting out and reduce the runoff risk with that. I suppose, there's a couple of overwhelming messages or points to note, I think, with a case study. And the case study works whether it's what enterprise is on the farm or what size is on the farm. Or the enterprise stock and rate independent. Points to note: one size does not fit all fields, and we have to really try to look at that. With the slurry that's produced on that farm, it could be as simple, you could say, look, 1,000 gallons of slurry to every acre on that farm, and that will use up the slurry that's produced during the winter. It'll use it up perfectly, it's all allocated, but is it going to where it should go? I would argue not. If you go back to the figure of what's produced there, and if you look and you allocate, to that the poorer fertility soils, the out farm where 2 cuts of silage are taken, and you balance that with 3,000 gallons of slurry per acre. And if you go back to then the next most critical low index P and K, where there's 1 cut of silage been taken, and you give that 2,000 gallons of slurry, we actually have allocated all the slurry that's produced on that farm during the winter. We didn't get to go near the grazing ground, but we have put it where it needs to go, and we have put it where potentially there's a longer term reward, because that's where we're really dependent on our high productivity, more intensively farmed soils. So one size does not fit all of that. And remember, there's not an endless supply of slurry on all, in the farms. It's not the case that, that we'll be able to go everywhere every year. We need to be very conscious with this case study and with others as well, that out farms and hard to reach places, have to be a focus. There has to be a real concerted effort to go in there. Some areas are more risky than others, but we do at least have, tools available to help identify those and manage them accordingly. And then I think key really is, it's very easy for me to talk about this, but if tanks are full the middle of January, slurry has to go. There's no question about that. Sufficient storage and planning is key. Sufficient storage to allow flexibility about when, and planning to address those things like fragmented farms and out farms and areas. That's now is the time to think about that. I suppose just a quick note, when we are talking about slurry storage, the 60% grant, the nutrient storage investment, is now open. There's a separate ring fence ceiling of €90,000 on that 60% grant, and it will cover things like manure pits and mass concrete tanks and so on and so forth. So, it's just something we need to keep in mind, that the value in having the value in headspace alone of having sufficient storage and not have to worry about tanks full, when you're heading into calving season or whatever else, I think is worth it alone, let alone the improved use that you'll get from the slurry when you really can target it to where it needs to go. So look, really in summary, just, what a slurry really is a hugely valuable source of nutrient on the farm. We need to optimize how it's used, use it efficiently, and when we are using it, to reduce our reliance on our chemical inputs, we do have the tools, the maps, to assist us in how to target that, and we need to use those. And I suppose a call to action, really, I would say is, we're at the start of the year. Let 2025 be the year when you really put the effort in and get the most out of those organic manures in particular, but be always, always cautious with them, the risks they bring with them, and really try our utmost to protect our water courses. It's in everyone's interest. So I'll leave it at that, and welcome any questions.
That's brilliant, Fiona. Thanks a million. Really comprehensive, and I actually really loved the way you dug into it properly. Sometimes when we're talking about this stuff, it's very high level, but you really dug into it, made it really practical. I think, and hoping any farmers that are on today will have got a lot from it. And I think they will have. A lot of compliments coming in, and just remind everybody just to put your questions into the Q&A, and Eoghan's going to ask a few questions in a second. But Fiona, you've talked a lot about slurry today, and I always wonder, and you mentioned hydrometer test at the start, we have these massive tanks of slurry, and I think you were talking about 28 or 29 euro per 1,000 gallons. Why aren't we testing more? It's like we test silage, we test soils, but why aren't we testing a couple of tanks that cost feck all and has such a high impact?
Yeah, I think you're absolutely right, Cathal. We tend to think that slurry is a homogeneous type substance and that it comes out of a tank and it's all the same. And it's hugely, that's so incorrect. Every 2 or 3 tanks in the yard, be no problem to see very different values within the 1 yard. And it's a simple process to do. A slurry hydrometer is a very easy piece of kit to use. All we're asking is, the basic, safety measures around tanks and obviously sampling. But, an agitated sample, it's very quick, it's very simple, and it'll give you a really good correlation to what's there. The other thing I should say is that if you don't want to do that, perhaps you're in an area where you're eligible for the Farm and for Water EIP, and where one of the measures covered under it is actually a proper slurry analysis carried out by a lab. And that's very easy to do as well. But either ways, I think it's you're right, hugely useful. Will really inform you and will really help to target then and get the best out of what we're doing. You're right, we should be doing more of it.
I know you mentioned to me before we came on, Fiona, that you wanted to talk a little about sulfur. Can you give us a few benefits of using sulfur in the nutrient management plan?
Yeah, I suppose I didn't include sulfur in there in that, and I really should have. We know that there's a really big impact, a really beneficial impact of including sulfur in your fertilizer plan for the year in terms of improving nitrogen utilization and nitrogen efficiency. It has been shown there's a lot of research done that grass yields can be increased by up to 2.5 tons of dry matter per hectare per year by inclusion of that 20 kilos of sulfur. And I suppose that's fine. That's an increase in the production. But the other thing that we don't see is that the reduction in the nitrogen leaching then. So we do hear all these media pieces about nitrogen and estuaries. We know that, application of that sulfur on an annual basis will reduce nitrogen leaching by over 20 kilos per hectare. And that's something we mightn't see, but is critically important in the whole conversation about water quality and reducing nitrate leaching. So it's to factor sulfur there into your fertilizer program. There is sulfur in our cattle slurries. It's just not in as an available form as we would like it to be. So factoring in the chemical fertilizer side of it is crucial, to catch some of that benefit that I've mentioned.
Yeah. So there's kind of a comment here and a question in it, Fiona, for the bigger farmers in the country. What's to stop them spreading all their slurry in the same fields over and over again, maybe driving up the nutrient value in those fields?
Yeah. Look, what's to stop us, I suppose, is some of the things I've just the common sense, or the really delving into it. Yeah, surely that will get slurry out of a tank and onto a field. And if that's your aim, then you've achieved that. But if your aim is to use it efficiently and wisely and to benefit financially from it, then that's not going to achieve that. You're not replacing, the need on the rest of your farm for it to be balanced up. You're not balancing your stocking rate, adequately over the whole farm, and you're really, it's I suppose to an extent it's a really inefficient way of managing what's first and foremost at hand, what's sitting there in the yard. You don't have to order it in, it doesn't have to come in a lorry, it's there sitting already. So whilst that is a way of getting rid of it out of a tank, that's not going to do anything long term. In fact, that's going to increase the risk of our nitrate leaching. It's going to reduce the kind of financial viability that goes along with this huge asset, this money in the bank, as you've referred to it yourself in previous talks. So we have to get away from that.
Yeah, look, the Department of Agriculture regulates the amount of slurry built out spread on the farm, but like exactly what you said, Fiona, if we spread it incorrectly or unevenly across the farm, it just costs us a fortune. It's not good management. So yeah, that's perfect. Eoghan, a few questions are coming up.
I suppose we'd want in there to start. A farmer with no slurry, no fertilizer out yet. Is it too late to soil sample?
No, a really good question about soil sampling. I mean, my concern with soil samples is not, there's no issue in sampling today, provided, as you've just mentioned, that no chemical compound fertilizer or organic manures have gone out in the past 3 months. If it hasn't, then that's fine. You're getting a really good baseline level of the fertility that's in the soil. Okay, there's a lot of samples going into the lab. You might have to wait for your results to come back, but they're still worthwhile doing it. The converse of that, Eoghan, is where you have gone out with slurry, even if it was a light coating, to take a sample from that land is not going to give you a genuine baseline of what's in the field itself, and that's going to confuse the situation. So no slurry, no fertilizer gone out, not too late, certainly not too late, and I would encourage going sampling there even today.
Perfect. Part two of that question: how late can a farmer leave it to spread line?
Yeah, look, I suppose really and truly here, what I'm concerned about when I hear lime at this stage of the year is where fields are going to be planned for silage later on in the year. None of us know what way weather conditions are going to be for the next month or 2 months or whatever. And the concern of going out with lime now on those fields destined for silage, to me, it's too risky a practice at this stage of the year. So I am more inclined to say on those silage lands to go take your cut of silage and then come back in afterwards and go then. Grazing ground, slightly different scenario. I wouldn't be as concerned, but the silage is the big one, and I think at this stage, it needs to be left off.
Another question in from a farmer. He's considering going with urea. Should or shouldn't he, or when should he go?
Yeah, look, I was just looking at the predicted rainfall figures for the coming week, and there's very little rainfall forecast. Okay, soil temperatures are a little bit on the low side, but on the positive now, we're into February. Our daylight is increasing, our day length is increasing. So really we're coming into a situation here now where we will be able to see that response. And you'll see from the figures I showed earlier there that, once we're getting into February, we're really at a time when grass is starting to take over. So I would think, look, we're probably looking at something around 18, 20 units of nitrogen in that protected urea form, where there hasn't been a slurry application already. If there has been a slurry application already, you've already given it its nitrogen complement. There's no use in double doing that. Hold off on that. But I do think, now, look, I will put a caveat there. Ireland is a big country. There's big variations from where you go down south to maybe some of the more difficult lands in the north and west. But we're certainly at a point where we're into spring now. We need to get something out there to support that plant growth in either form, either in chemical or in organic. I would caution that if slurry storage capacity isn't an issue, then the longer we can hold off with that slurry, the better. And if we can push it out to the end of February, all the better, to really maximise the efficiency of that.
You're on to the next question there now from a farmer. I have space in my tank, but I'm nervous that I'm going to miss the window. So I suppose he's nervous after the weather we had last spring.
Yeah.
He's going to go with that light coating. How light should he go, and what's the simple distance to keep from all the drains and rivers and stuff?
Yeah, this is a really good question. Like it's at some stage you have to make a judgment call on it. If you have space in the tank and it's not a concern, the closer we can get to the end of February, if we had all the storage in the world, you'd probably say early March. But to push it on to really kind of match that. That said, there's not endless storage in every tank in the place, and where we are going out, I think the rate, what you mentioned about the rate, is really important. Not every tank has to be emptied. So if that man is going out with slurry, it's not a case of having to empty every tank down to the floor. Take a couple of feet off of it. And in terms of rate then, really I'm more cautious, and I'm thinking about 1,500 gallons per acre at this stage is a very light coating, but it's still sufficient when you go back to the growth rates that we're expecting in the like of February. And that means that you still have a volume there for when growth rates pick up, soil temperatures pick up, and you really get bang for the buck later on. In terms of the second part of that, I think it was about your buffer margins.
Yeah.
Look, if you're in the later zones in the country, then that 10-metre buffer margin applies for the first 2 weeks of the open season. And I suppose we should mention that 10-metre buffer margin should apply all year round, where we're looking at fields that are sloped down towards water courses, because there's a greater degree of risk there. And what it applies to is our surface water drains, the very same as our tributaries and streams, because those drains are connected and will eventually be the bigger stream. And I suppose, but outside of those sloped lands and outside of that initial 2 weeks, that 5-metre buffer is critical all year round on the rest of that land. As I say, the intention isn't that you get runoff, but where the conditions could lead to runoff, that's your safety belt. It costs nothing. It's just the conversation, as I mentioned earlier, with the contractor or whoever's spreading it, that we're all aware that it's worthwhile to do, and it really is effective in reducing that risk.
Yeah, so it could be important for the farmer just to mention to the contractor, I'm not going to eat you if you keep out a little bit.
Yeah, I do. I remember speaking to a contractor a number of years ago, and there was a particular customer that he spread for, and the instruction was to go as close as possible to hedges, drains, cover the field. And over the intervening years, I think we've really kind of changed that attitude to say, look, that margin is doing a really good job, a really critical, important job, but only when the conversation is had, as you said, with the contractor, or if it's not a contractor, if it's a son or a daughter or a young lad working in the yard at the weekend, that they know that there's an importance placed to that conversation is had, and it's clear, stay out the 5 metres.
I think that's a nice way to finish. Unfortunately, we're out of time. It reminds me of the old saying, I know I didn't say it, but that's what I meant. So communication is very, very important. So look, just want to finish up there and just like to thank everybody for submitting their questions. Excellent as always, and apologies we didn't get around to all the questions, but we tried to get through as many as possible. And Fiona, thanks a million, an excellent presentation. And there was loads of comments on how enjoyable and educational your presentation was. So lots of really nice comments there for you. Thanks a million. Owen, brilliant as always on the questions. Thank you so much. And just also like to thank Eoghan in the background. She is the driving force behind this webinar, and she's always working away, keeping us on the straight and narrow. And next week we can look forward to a chat with Emma Buckley, who is Teagasc PhD student, who will discuss lowering the carbon and ammonia footprint of the low-carbon dairy farms. And just to keep an eye out as well, the low-carbon dairy farms will be featured on Ear to the Ground next Thursday, the 13th of February. And Emma's going to present some of the results next week on this webinar at 9:30. That you will show on Ear to the Ground. So it's not to be missed. Very interesting topic coming up. So, but until then, I hope you have a great weekend and slán go fóill.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.